Assalamualaikum. My name is Amrul Haziq bin Jeffrey. My metric number is AE190038, and today I'll brief about final year project that is a smart wearable device for fall detection using inertial sensors. For the abstract, as we all know, falls are a significant public health problem that leading to many injuries and death every year. A portable fall detection system that can detect falls and, if necessary, notify emergency service without user intervention has been developed. Through the Internet of Things, also called as IoT, the system can receive data in real time and notify the family. About this project, falls are a serious public health concern that affects people of all ages and backgrounds. According to the World Health Organizations, so-called as WHO, falls are the second leading cause of unintentional injury death worldwide, with an estimation of 684,000 individuals dying from falls each year. Therefore, a fall motion sensors are designed to detect when a person has fallen and to alert caregivers or emergency service. They are becoming increasingly popular as they provide a practical and cost-effective solution. So for the problem statement, the problem to be addressed is the high incidence of falling events among older adults living in assisted living facilities. These falls can result in serious injuries and a decreased quality of life for the individuals affected. The goal of this research is to improve the accuracy and user-friendliness of fall detection system and also to reduce the power consumptions of the system. And to make sure of it, some specific methods or technologies that may be used to develop a new fall detection system, which is including sensors, machine learning, and also the algorithms of sensor fusions. Negative impact on health and well-being of individuals who are at high risk of falling due to mental and physical fatigue, medical conditions, and also certain medications are really high. This problem is significant as it can have the negative impact. To justify this problem, fall detection systems are really important to prevent injury or death and also to provide assistance to those who may not be able to call for help after a fall. The objective for this project are mainly to develop a smart wearable device prototype for fall detection using inertial sensors. Secondly is to design a motion classification algorithm based on machine learning data analysis. Thirdly is to design a wireless emergency trigger system that can trigger emergency SMS for emergency service. And lastly, to reduce the power consumptions for this system. For the methodology, there are 5 different stages to complete this task. First stages of this project, which is planning. It is crucial to complete the project within the time frame and meet the project objective and goals. Proper planning is required to ensure that the project runs smoothly and all tasks has been completed in time. To achieve this, Gantt chart and a key milestone have been created. The Gantt chart provides a visual representation of the project schedule and it helps to identify the critical path. Other than that, regular meetings with the supervisors are compulsory to update the progress of the project, and feedback from the supervisors is very useful to improve this project. The second stage of this project is designing, which is crucial in making the project complete with a beautiful process. To overcome any potential problems smoothly, brainstorming ideas and solutions are required. To generate these ideas, input from the supervisors is crucial. Once the multiple ideas are generated, it is important to combine them to create the alternative solutions to the problem at hand. Thirdly is the implementation stages. The purchase of the necessary components is the next step in putting this project to action after it has been designed. These parts are mostly purchased from a shop from Farid Raja Taman University and also has been given from the supervisors. Because of no waiting time for the parts to arrive, the prototype of the project can be completed within shorter time. The supervisors testing, which is an essential step in determining the prototype functionality and effectiveness, is the fourth of this project. During this stage, the prototype will be subjected to a variety of tests, including front fall, back fall, left and right side fall. These tests are meant to gather the acceleration and orientation data and contrast it with the data from the previous studies. And last but not least, the evaluation stage. During this phase, the prototype is put through a series of tests to make sure that it can accurately distinguish between faults and other activities of daily living and is reliable in detecting them. We go to the fault detection algorithm. First, when the system has been started, it initializes the sensors. Then it measures the magnitude accelerometer. When the full acceleration detected with recovery, it goes back to initialize the sensors. But without recovery, it goes to check for orientation using gyroscope. Then, if the orientation detected with recovery, it goes back to the initialize the sensors. It's reset backs. Then without recovery, it triggered an alarm on prototype. The user's inputs to close the systems. If the users close the systems, it's reset back to initialize the sensors. But if it's not, the system track the current locations. Then it sends the location data to important persons, and the alarms continues ringing. We go to the major requirements for this prototype. Actually, there are six components that has been used, which is first is not MCU, MPU 6050, I2C LCD, not MCU baseboard, battery, and a battery holder. But for the major requirement is the not MCU, MPU 6050, and also I2C LCD. Not MCU is an open source platform that is built around ESP8266 microcontroller. Meanwhile, for the MPU 6050 is a sensor module that includes an accelerometer and gyroscope in a single chip. With the MPU 6050, we can find the accelerometer and also the orientation data. And last but not least, an I2C LCD to show the data for the acceleration and also the orientation. We go through the preliminary results for this prototype. As you can see, this is a graph for acceleration versus time when the prototype is in static positions. For example, the prototype is seen like this. It has an I2C LCD It has an MPU 6050 and the Node MCU is on the baseboard. So the MPU 6050 is in static conditions. Then when the MPU 6050 has been 45-degree motion clockwise and counterclockwise on the x-axis, such as like this. When we move it like this, the acceleration x will move. The acceleration x will the acceleration data for x-axis will increase and decrease simultaneously. Then for same goes with the 45-degree motion clockwise and counterclockwise y-axis, such as like this. We move it 45 degrees like this. So the result of the y acceleration will be increase and decrease. Same goes to acceleration when moving forward and backward. Like this, we just move it forward and backward. The result for the acceleration x will have some different measurement. And finally, for when moving left and right, you just move it left and right. The result for the acceleration y will change. So here is the Gantt chart for this final year project. On week 1, we have supervisor choose via SMAP online, a talk seminar for the final year project, and also the discussion with supervisors on week 1 and week 2. For week 2 also we have a proposed title via SMAP, and then we goes to the chapter 1 introductions in week 3. Then on week 4 until 10, we do chapter 2 literature review, and then discussion with supervisors on week 5 until 12. Then after discussion with supervisor, we go to the chapter 3 methodology on week 8 until week 12, and also expected result chapter 4 on week 9 until week 12, and also for the abstract on week 12. After that, submission of FYP1 draft report to supervisors on week 12 to 13, final checking on week 13 to 14, and then submit report on week 14, prepare slide presentations on week 14, and finally oral presentation FYP1 on week 14. That's all from me. Thank you.